Yes, e-learning platform. You guys, this is gonna be the first first chemistry lecture. So I wish this gonna be a great one. So I would like to start with all the things. Um, so I guess I'll be taking carbon and its compound. So give me just a second, BRB, for 1 minute. So now if I gonna take it, um, now let's just continue and let me just give me a time. I'll just erase this in a minute so that it would be easy for everyone to visible my whiteboard properly. So if I'm starting with carbon and its compounds, it means it is a very important chapter as I see, and I can't even omit it. So just give me a minute. So here we see as carbon. Actually, many members might be thinking that why am I taking this soon and very early. This is a topic where it exceeds to more revision and so and so. So I would be requesting you to please and kindly pay attention. Okay, kindly pay attention and through this, so that I can even confirm that you guys are okay with it. Um, Now If I'm going through it further, I can tell that carbon atomic number is 6, electronic configuration is 2 comma 4, and valency is always 4. Valency is nothing but one second, I'll write it so you'll get to know. It's atomic ATM, or not ATM, atomic mass ATM is, so you'll study in 11th. Atomic NO dot is 6. So config, what do you think the config is? Atomic configuration, I have already told you, it's 2 comma 4 just now at the beginning. Now, so it is the electronic the sorry, not electronic, the atomic configuration is 2 comma 4, and there is nothing that changes that. So if I am going further, it's there is a valency. Right, there is a valency, which means that if there is an atom, for that atom, okay, just keep this as an atom. If K, L, M, and actually it should not be K, the innermost should be K. So K, L, M, N, O, P, so and so. In that, if I am taking the outermost shell, for this we have only 4. So the outermost shell will be 4. So henceforth, if we go, if some might have the question, why 4 not including 2? Here, according to the rule of the shell, I can tell Thomson's model, I can tell you Thomson's model, I can tell you Bohr's model. Here, if you are taking Thomson's model, you are only focused on, see, just give me a minute so I can explain you virtually, and not confusing it too. Okay. So if I'm going through this Thomson's model, just Thomson's model, what do you come through is that you can see that this is an example of watermelon. It's an example of watermelon. So when you're seeing through the example of Thomson's model, you are coming across the one of the example of watermelon where it has seeds in it. I guess, yeah, it has. Sorry, it has seeds in it. So these seeds are mainly like acting as atom, proton, electron, neutron. Thomson's model do not match our carbon and compounds, but for example showing this outermost shell, for that I have shown. So when I move on further to the main topic, your carbon, the valency, I'll just valency, I'm writing it as valency. It has 4. So the outermost shell is 4. So in first orbit it has 2. So in second it should be 8, but carbon has 4. Okay, so and so it goes on further. So here I wanted you to know a main thing. Okay, it's so important, and no need to make it this makes you to not make any mistakes further or future in any future. Actually, what all we study in 10th, in 11th they prove it as wrong. We So I'm not gonna go through that, because saying that demotivates some students, that why do we need to study the unwanted thing, and which is wrong. But according to the 10th knowledge it is correct, but according to the 11th and 12th knowledge it is wrong. So when I go to valency, I have taken this valency. Now there is a question for me, for you, not only for me, for you guys. It is gonna be a playful question. Carbon neither carbon neither gains nor loses for E minus. This means electron. Okay. Just get to know that this is E minus is electron. This is just a short form. So electron. See this, the word which I'm gonna write would be important in the answer. Okay. Okay. E minus electron. So carbon neither gains nor loses 4 electron to attain its noble gas. See, all might be thinking of noble gas. Oh, what? How sudden noble gas came? What in the world is noble gas? Some person's question would be this. Don't worry, don't worry. I'll just write it one more word. Stability. Okay. Just stability. To attain its stability. Noble gas. One more meaning. Electronic config, because so here you might, I guess you might, some might have the answer and some might won't. So I'm just moving this down to answer. Okay. Here, let me okay, if I'm taking the solution, what do you think is the solution? If an electron, or if an atom gains 4 electrons, okay, if atom gains 4E minus, so you should remember E minus means electron, not only electron. So E plus is loses, E minus is gains. When it gains 4 electrons, carbon would have 10 electron. So therefore 6 proton cannot hold 10 electron. Makes sense, right? So if an atom gains 4 electron, carbon would have 10 electrons. It is E minus, don't get confused. 10 electron. So therefore 6 proton cannot hold 10 electron. So this might have been understood by you guys. So once I go further, it can become complicated. I can teach you playfully. This class is gonna be playful. I'm damn sure it's gonna be playful. And then he went so funny too. So when the carbon gains 4 electron, it's telling that it will get 10 electron. So because 6 plus 4 10. Okay, so because of that only, don't think that I don't know math. Okay, 6 plus 10 is equals to 6 plus 4 is equals to 10, sorry. So what do you think that when carbon, wait, let me just change into this. What do you think that when carbon loses 4 electron, what do you think? What will happen? Many might have know that this, it's just a common. So if an atom or carbon, actually this is not an atom. I forgot you to tell that. This is never an atom, it's only a carbon. This is also not an atom. Carbon. Okay. If a carbon loses 4 electrons or 4 plus E minus. So just remember, 4 plus E minus stands for losing the electron. I come up again, losing the electron. So if an carbon 4 plus E minus, so where it loses 4 electrons, what do you think it will happen? Can it be stable? This is so important. Just know it. I'm not telling that it's so compulsory, but it's just a basics of chem. When you come to the basics of chem, you get this. And let me keep this secondary as black. So okay, if an carbon loses 4 electrons, can it be stable? Never. Okay, just if it loses electrons, carbon would lose 4 electrons, leaving only 2. Okay, it will have only 2 electrons. It will be having only 2 electrons. Okay, so this needs, see, this is important note. This whole thing is important note. Just write it as note in your notes. This actually, when it loses 4 electron, it will be having 2 electrons. So this needs lot of energy. What? Lot of energy. Okay, this needs lot of energy and makes carbon unstable. Carbon unstable. So funny, right? Chemistry is so funny that you know that one will not depend to each other, but we say that it depends to each other. I know that this doesn't make sense. Just to make you feel better, I'll just give you an example. See, a guy named Thomson. I just told you about the Thomson's model. He comes and tells that the structure of atom is like this, a shape of watermelon, so and so fruits, having seeds. So a guy, Thomson, proved that this atom is like this. He didn't prove, he just said hypothesis. You can call this as hypothesis. Hypothesis is which not proved. Hypothesis, just knowing you to learn fun. Okay, hypothesis. This is an hypothesis. So A guy coming and telling that an atom is like a watermelon, and there is another guy coming and telling that it is wrong and the atom is like this. Having K L M N O P so and so. Here there is a mole concept. Here in 11th you read mole concept, in 10th no mole concept, because CBSE students will not have mole concept. Only ICSE students will have mole concept because they are far ahead than us. So and when you're coming through mole concept, you read this. So just forget it about. Just forget it. So nothing is correct except math. I tell you, I will teach even math. Like, see, first standard we studied 2 plus 2, which is equals to 4. Right? Now we study 2 plus 2, which is equals to 4. There is no one that can come and change. No, sir. It is 2 plus 2, which is 3. No one can come and change. Okay. So this is the difference which we wanted to learn. Mm. And think practically. So I just want you to know this, very 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 important. This is basics, so it's important. Always the first lecture, first class of everything is important. Even I should have studied. Okay, forgetting that. Now teaching with you guys, having fun, and learning for myself, improving my basics, and stronging up of my basement would be my positivity and my positive things. So now I guess you might have understood this. I don't think so that no one is having doubt in this topic. I'll be going into the one of the main thing. Don't think that I have started this much early, bhaiya or bro. How will I know this? I don't know even carbon. I don't know what is chemistry. There are people who don't know chemistry. I'm not here to tell that it is wrong. It's not their mistake. It's not no one's mistake. Focusing is important. So now I'll go into egg structures. I call them as circle and egg structures and ring structure. Anything you can call it as. Okay. So formation of H2 molecule. So when you think, what is this? Formation of H2 molecule. So H gives H2. That's it. What is there the other thing to do in this? What is that much big thing to do in this? See, the main focus of this thing is, it's like a Venn diagram, so no need to worry. So I'll keep a dot instead of into. I don't think so it is a dot. Okay, enough. I guess you can't, I actually, because for now I have zoomed 99%. So here one and here one. Instead of into, I'm just keeping dot, just to, if I'm keeping the dot, will it be okay that H and H can be combined with each other? Actually, this is incorrect. I know. To just tell you the difference, I'm just doing like this. But the actual thing is like this. Okay. So when it is like this gets circled, this gets circled, forming single bond, H bond H. So this is important. Just note it down. Just jot it down. I'll just, or else in simple word, this is shared electrons. Okay. Just note it. Just note it. I'll give you time. Or I have kept the settings that after the class you can watch it too. You can watch it. There's no issues. So I guess you are clear, very clear with this topic. So let me go to the one more question. I'll give you a question. Just let me give you a timer for that, and let me see how much memory can solve that. Actually, I know my life. I don't reach that much views. Even though anyone seeing it can try and send the answer later in comments. I can watch that, and so now if we are going further, and one more thing is I had a comment telling that it is a is it going to be a paid promotion? No, I don't know how to do a paid promotion too, because I'm a beginner, so I won't do those things too. So I feel it is not good, and I'm okay. Focusing on question. Going on question. Okay, so formation of oxygen molecule. What you are gonna do? Formation of O2 molecules. So I give you 1 minute 30 seconds. Going. Wait for the timing starts. Your time starts now. You are a beginner, so I'm giving 1 minute 30 seconds. If not a beginner, I'll give only 50 seconds. So be careful. If you have subscribed and watching this and so on, so, you'll be having only 15 seconds. 50 seconds, not 15 seconds. 50 seconds. Not subscribed, also 50 seconds. Don't worry, all are same. For me, all are same. It's gonna be time up, guys. 8, 7, 6, 5, 4, 3, 2, 1. Time up. Okay. For them all who have solved, I am giving a great applause, and who have not solved, also it's okay. Who all have given a try is also okay. So who all have done good, they should give me 1 subscriber. Who all didn't attempt, they should give me 3 subscriber. Who all have tried should give me 1 subscriber. Just for fun. Okay, so going through this topic, oxygen, and it is so important where you should remember atomic number and for 10 atomic number and valency. It is so important where you if they'll wake you up at the night and ask you, so you should answer that, because this is important. This is the basics where it helps 11th a bit I'm telling a bit, really a bit. But the periodic table should be at least, if you are knowing till 32 or 40, it is enough, really. I wish you guys do that. So okay, so going on to that, here hydrogen, I'm just writing in the atom. I guess no need to write. I'll just tell there I have even less time, so I also need to go. Even though I'll complete the lecture and I'll complete the topic until I have uh, choose. I have set my mind to complete. So formation of O2 molecule. If you are going to the formation of O2 molecule, I can tell that oxygen has 10, 10, valency 10. Yes, sir. Valency 10 now. Okay. I can tell that oxygen has valency 10. Yes, no. Yeah, right. No. What? What is this guy? Some might think, what is this guy telling valency 10? Oh, damn. No. Valency is not 10. The valency is outermost shell, so valency of oxygen will be 6, of course. So I'm gonna keep it like this. Just note this. Actually, valency is 8 for oxygen. Not valency. Normally, there is 8 electrons. Total 8 electrons. So outermost shell has only 6 electrons. So it needs 2 more electrons to attain its stability or attain its noble gas. So I can borrow from mother oxygen, because you need O2 and formation of oxygen is also done through that. So once again, I have made a mistake. So I'll just keep this all like this. It's so funny in doing like this, but this makes more time, so I'll just do it fast. Yeah, okay, enough. So if I'm coming through this, it needs, both needs 2 so I can take 2 from this and I can take 2 from this. There is nothing wrong by taking 2. Okay, so this becomes double bond. Just say this is creating double bond. What do you think is double bond? We say O is 2. Do you think this 2 is double bond? Oh, sorry, it looks like quadrilateral bond. Sorry, not quadratic bond and so on. So it's double bond. See, this double bond, I'll just mention it in different font so that okay, this is double bond, right? Do you think it's from this too? Because of this two, it is double bond. No, it attains stability by 2 electrons. Understood? Understood? I guess you might have understood. I'll repeat that again. So to attain its stability, it don't have 2 electrons, and this don't have 2 electrons. So total 4 electrons. But we are forming O2. What? O2. So in the form of O2, you have 2 O's. Just normally, just for understanding, I'm just doing like this. Two O's you want. So if you want 2 O's to be connected and stable, okay, being a single atom or a molecule, you need four electrons for stable, but for each oxygen molecule you want two electrons. So that is what O double bond O. Just understand that. I don't wanted you to be confused in how did that double bond and what is that double bond. Now I'll just go through the last example, which is nitrogen, and this is tricky. Formation of nitrogen. I'm just giving you the question. Formation of nitrogen. No need question. No time. Formation of nitrogen. Okay. So nitrogen 7. So outermost is 5. So I'm just keeping it like this. You might think each 2 2, right? Yeah. Okay. 1 2 3 4 5 6. But it's not 6. Okay. The same thing. 1 2 3 4 5. It needs 3 electrons to attain its stability. Do you think it is correct? Yeah, it is absolutely correct. It wants 3 atoms. Oh, sorry. Oh, I keep saying atoms. Sorry. It wants 3 electrons to attain its stability, but the order is where it cannot be attained. It can, but the ordering we need to. Okay, sorry. The ordering thing we need to simplify one. Okay, ordering we need to do it clearly. So 1 2 3 4 5. 1 2 3 4 5. So 1 2 3 4. So 4 plus 5 8. So second electron is 8. Remember. So second shell. Okay. So second. Okay. 1 2 3 4. So this also needs how much? Actually, I made a mistake. I guess some might have noticed. Okay, this x thing I have made wrong. Why? Because 8 should be there in second electron. I have given each 9. So only 1 2 3. 1 2 3. Both need 3. So I'm taking from this neighbor. Sorry. And this neighbor, nitrogen. So before we saw O double bond. Now here we see nitrogen triple bond. Today the class is going so smooth, so I'm so happy for that. So I guess this would be so nice if it goes completely like that. So this is triple bond. I guess you might have understand. So you can't even tell n as 2 n2, so that is completely wrong. So I guess you might have understood the basics now. Now I just this basics would be enough for you guys. I'll be taking part to not tomorrow. I'll be having college 11th. So next topic would be actually the next topic where the next week or this Saturday Sunday I'll be free. I'll be able to take you through for the classes. Chemistry, mainly chemistry, mainly chemistry part 2 lecture will be coming this week. I'm damn sure. Okay, I'm so damn sure and so glad to take classes for anyone and anyone who needs it. And so, next topic, just note this. Next topic is formation of methane. Okay, just keep it, formation of methane. So I'm so glad teaching you the basics. I guess you might have understood. And the first important question is so important. I have already told it is important, but it is very important. uh, if the teacher, while she's gonna teach, he or she, sir or ma'am is gonna teach, you don't need to um, think how this happened, how some teachers are there good with good explanation, but some are also there with very good explanation. Okay, it's according to the children or the student is listening.